So let's look at one like this. Here's what Michelle's talking about. It's something like a problem like this. Now the way it would be written in Math Excel, so what is the inverse of that? Let's just find this real quick. So they would have said,
Wait, which one are we doing exactly?
70, let's do 76.
Okay.
Right, so then we're gonna end up with the arc. We're gonna end up with the 1/2 the arc cosine of x would have been the function that they would have asked you to do. They would have said something like this. They would have said f of x equals 1/2 arc cosine x. Did they give you a point then too?
Yeah, like, okay, the one I had was, 5 arc secant 5x, and then x equals 2/5. That's all they gave me.
X equals 2/5. Okay, so then they would have, so this one would have been, let's see, it would have been 0, so it would have been, it would have been 1, 0 would have been the point. Okay? So we can get rid of this thing now, really. We don't need that. That's the kind of problem that we would have. And they would be asking for. Should I turn off the? Are you guys? Is this gonna make it too hard to take notes if I do that?
No, you're
Okay.
perfect.
Yeah, it shows up on that. Isn't that nice?
Oh, yes.
Okay, so then, so then they want to know what is the equation of the tangent line at that point. Is that what they're asking for?
Yeah.
Okay, so right?
Mm-hmm.
Okay, so then we need to know the derivative of that function, right? The slope of that curve at that point. But what we're going to do instead is we're going to say, let's let
Are you recording this?
g of x, I am recording this. G of x is the inverse function, let's say instead, right? Just makes the notation a little simpler. So then we know that f prime of x is equal to 1 over g prime of f of x, right? Okay, I just want to make sure I'm using the exact notation, yeah, of the, well, hold it. They have g prime. Okay, so, yeah, that's fine. That's how we would do it, yeah. Right? The derivative of this function is equal to the reciprocal of the derivative of the inverse function, which is convenient for us, right? Because the inverse function, we could find out what that is. G of x we know, right? If we, that's just going to be the cosine of 2x, right? If I find the inverse of this, if I set that equal to x and make that a y and I solve for y, I would just multiply each side by 2, so I get arc cosine y equals 2x, so y equals cosine 2x. Everybody agree? Okay. So then this is easy to find. G prime of x is what?
Isn't it 2? Wasn't there a rule like 3/2, or was that was?
So this is just a plain old derivative. What's the derivative of cosine 2x? You can change it.
Negative sign.
Negative 2 sine 2x, right? Okay, so then the point that we had was at 1, 0, right? So then this is the point right here. This is the point x f of x, right? So that means that the point 0, 1 must be the point for the inverse function. That must be the point x g of x, right? You see what I'm saying? These are the whatever the input of the original function is going to be the output of the inverse function. Right? Everybody get that? So okay, so I just want to make sure God, the notation on this can be so, I mean, I know what to do, but I want to make sure I'm going to write this in the way our book does so you guys will know what to do. So this is going to be what we said in the book. Do you guys have your books with you?
I stopped hearing my
Okay, let me just grab a picture of this because I want you to be able to reconcile this with our textbook. Let's go up. I want that blue box right there. Okay. Okay, so does everybody see this here? So if f is a function that's differentiable on an interval, and if f has an inverse, and g is the inverse, right? Right. So for us, what we said was we're looking for, see, ours would have been defined backwards. Ours would have been, in our book, they would have defined f of x as being cosine 2x. And they would have been looking for the slope of they would have asked about the slope of the inverse function, which would have been this. The inverse function is 1/2 our cosine of x, right? Does that make sense? So then theirs looks like g prime of x equals 1 over f prime of g of x, but ours is going to look like f prime of x equals 1 over g prime of f of x, right? So what's f of x? Well, f of x is 0 for this point. You see what I'm saying? So I think this part was going to be confusing. My point is just that the input value here for the inverse function, let me do it this way. I think this will be clearer. So for the original function, this is the input, and that's the output, right? For the inverse, it gets flipped. So 0's the in, and 1 is the out, right? So we're just taking the reciprocal of the derivative of the inverse at its input, which is the output of the original function, right? You get what I'm saying? Okay. So then we're going to evaluate this at 0, right? Everybody get that? That's an important thing to wrap your head around. It's kind of convoluted and
We'll just
complicated.
go through it one more time.
Yeah. So let's put this all in a bigger context. So we're trying to find the slope, we're trying to find the tangent to this curve at the point 1, 0, right? Okay, so that means that, well, we've got a point, we just need a slope, right? We need the slope of this tangent line, so the slope of this curve at that point. But we don't know how to take a derivative of this function, right? So we'll do a tradesy here. We'll say, okay, well, the derivative of f of x at this point is the same thing as the reciprocal of the derivative of its inverse at the corresponding point for the inverse, right? At the cousin point, the reflection about the line y equals x, right? See, that's a good trick. So then f prime of 1 is going to equal 1 over g prime of 0. Okay? Well, g prime of 0 is easy for us to calculate. G prime of 0 is just 0, right? Oh, hang on a second. Wow, so that's going to be a weird one, right? G prime of 0, did that right, didn't I? The point, they wanted the point, this one was on, I shouldn't have erased that problem. It was on the interval from 0 to pi halves, right? And they picked an a value of 1. And so when I put in 1 here, the arc cosine of 1 on that interval is 0. So I get 0 there. Okay, and so that's telling us that we're going to end up getting infinity. So it's a vertical line, right? So the tangent is just going to be the line x equals is just going to be the line x equals 1, right? Okay, when we put in an x value, we're getting back an infinite slope, and so it's just a vertical line x equals 1. See what I'm saying? That was kind of that's a bad example. Let's do another one. Let's pick one out of Math Excel. I tried to make one up out of the book, but let's just do one like they do in Math Excel.
Can we do the one I was working on?
Yeah, that's fine.
5.3 practice 2.
Question 3? Yes. Because it, yeah. You can- I got it so wrong.
So you already got yours wrong.
Yeah,
Okay, so what was yours then? Yours said
5 arc secant of 5x.
so that's we'll call that f of x.
That's what y equals, yeah.
Okay, so f of x equals, say it again, 5.
Arc secant 5x at x equals 2/5.
Okay, x equals 2/5. Okay. So then what we would want to do is, and they're trying to find the tangent line at that place, right? So let's calculate what the inverse function would be, right? So how are we going to do that? Well, we're just going to say, remember our strategy, we call that y. And we flip the x and the y, right? So we get x equals 5 arc secant of 5y. What do I do to solve for y?
8 5 by 5.
Divide by 5. And then how do I undo an arc secant? Secant. So I get 5y equals secant of x over 5, divide by 5. And I would get y equals 1/5 secant of x over 5. So that's going to be what we might call g of x. Okay? So then an input value of 2/5 there, right? So this is giving us the point 2/5 something, right? Equals an output value of 2/5 here, right? So that corresponds to the point something 2/5. Doesn't matter, we can solve either one. So if we want to find the corresponding x value here, like finding the corresponding y value there, same thing, right? We could just set Now, everybody maybe should watch this. I think this might be kind of important to see. So that's a y value. So I could just set, right, I'm just gonna set y equal, or g of x equal to 2/5, and then I'm gonna solve for x. So I could do that, right? Multiply both sides by 5. And then if I flip these to make this a cosine, I would get 1/2 equals cosine of x over 5.
Wait, when
Okay.
you have 1/2.
Because I flip both sides.
Oh, yeah.
Okay. So what's hand going to be? Cosine of what is equal to 1/2? And I'm assuming they're giving you, do they give you a domain on this, Michelle?
No.
This problem? They didn't give you a domain? Okay. So cosine of what is 1/2?
Basic. Can you remember? So you don't switch what's inside to your cosine. But you
No,
yeah,
because secant of hand is the same as 1 over cosine of hand,
Okay.
right?
Just making sure.
Okay, so then what is hand? Cosine of hand is 1/2 on the unit circle. Well, no, what's the angle though? We're looking for an angle, right?
Pi over 2.
Pi over,
I mean,
no, it'd be
It's
pi over 3, right?
oh,
Okay, so then that means that x/5 equals pi/3, so x equals 5/3 pi. So that means that's what goes here. And there, right?
you would have to go over
Okay, is everybody getting that part?
here. Oh, so then you just multiply. Okay.
Right.
So, I think I got what you did, I know you flipped the 2, but why did you flip the 2?
Well, because I didn't want to deal with, I don't like to deal with secants, I'd rather deal with cosines.
Oh, okay.
So I just took the reciprocal of both sides,
Oh, okay,
right?
that makes sense.
So that on this side I get a 1/2, on this side the reciprocal of secant is just a cosine. Cosines are a lot easier to work with.
I was just a little bit confused on
Okay, so what have we done then? So this is good. So now we can avoid completely having to calculate the derivative of f prime, right? So f prime of f prime of x, right? Or f prime of 2/5 is equal to 1 over g prime of what?
0.
5/3 pi. Right? And think why that is again. Let's not lose sight of why we're getting this result. Right? This result, this is just an artifact of properties of inverses. Right? We've got this. We've got the symmetry about the line y equals x. Right? So if I've got some function down here, and let's say that here is, I'm looking for, this point has coordinates, let's just call it hk, right? And if this is f, then f prime of h, let's just say that that's equal to a, okay? Well then what am I going to end up with over here? I've got the same kind of did I do that wrong? So something like that. Oh, let's just go up though. Should go up, yeah. Something like that ish, right? So what are the coordinates at this point?
KH.
KH, right? And if this is G, then G prime of K is just going to be the reciprocal of that one, isn't it? Right? You get that? Okay. If this had a slope of 5 and it was steep, this would have a slope of 1/5 and be shallow.
So G prime of K is equal to 1 over F prime of H?
Yeah. Right? That's our relationship that we're exploiting, right? If I calculated the slope of this function, well, this one has a reciprocal slope, right? So in this case, it's a lot easier to work with the inverse than it is with the original function, right? So f prime of 2/5 would just equal the reciprocal of g prime of 5/3 pi. Okay? So let's work down here. That's a lot easier, right? So then we'd end up with g prime of, well, what's that going to be? G prime of 5/3 pi equals, well, we never took a derivative, did we? Let's take a derivative. Right, so if there's g, what's g prime of x? What's the derivative of secant hand?
Secant and
Tangent.
tangent hand?
Okay, then times 1/5, so I get 1/25 secant,
Well, wait, where's 1/5?
because I've got to pull by the chain rule, the derivative of hand is 1/5, which I pull out front.
Right.
Okay. Secant hand, tangent hand. And so g prime of 5/3 pi equals 1/25. 5/3 pi, think where that is on the unit circle. That's 2 pi minus 1/3, so it's right there. So secant is the reciprocal of cosine, right? So what are the coordinates at that point? Positive, x coordinate's positive 1/2, the y coordinate is,
-3. Square root of 3 over 2.
okay, good. So then we end up with secant of, oh, hang on, secant of x over 5, so that's pi thirds. Whoops, so that puts us up here, right? Because we're plugging in, does that make sense? We're plugging in a value of x, and we're getting back a secant of x over 5, right? So if we multiply that by 1/5, we get pi thirds. So strike that. We're up there, right? We're at the point 1/2 root 3 over 2.
You go over that again?
Yeah, because look, if we plug in, this is giving us 1/25 times, we add one more step to this. Right, so we're gonna get secant of 5/3 pi divided by 1/5 is pi thirds. Tangent of pi thirds, okay, which is equal to 1/25. Secant of pi thirds, well, secant is the reciprocal of cosine, so that's gonna be a 2, right? Okay, tangent is the ratio of sine over cosine, and so that's just gonna be square root of 3, right? Okay, that makes sense?
Yeah.
Okay. So that gives us 2 radical 3 over 25, but then we want the reciprocal of that, right? So we're gonna get 25 over 2 radical 3. So I guess technically we'd want to rationalize the denominator. So that's going to be a 75 on top over, or no, it's going to be a 25 radical 3 over 6. Right? Okay, so that's the slope, right? That's M. Okay, and then the point is just 2/5 5 pi over 3, right? So you're gonna get an ugly answer, but now it's just algebra 1 stuff, really, with just some complicated fractions, right? Okay, so yeah, so what are we gonna get? Let's finish this up, make sure we get the right answer. So that's gonna give us, somebody write that down. So just write down this stuff, what that point is and what that slope is. We'll go to the next page and finish this up. Yeah. So M. And the point was 2/5?
Yes. 5 pi arcs.
Okay, so then we end up with y minus 5/3 pi equals 25 radical 3/6 times x minus 2/5 is the equation of the tangent line. And then we would just have to,
God, that's gross.
yeah, it's kind of gross, isn't it? So y equals 25 radical 3/6 x minus, if I distribute this,
There you go.
we're gonna get 5 radical 3/3 plus 5 pi over 3, so I guess we could, I don't know how they'll probably leave it like that, I'm guessing.
So shouldn't it be, no, never mind.
You see it? Because 25 over 5 becomes a 5,
Yeah.
2/6
For
becomes a
a second,
3
I
on the
thought
bottom.
you'd forgotten about the 2.
So is that the answer? Let's just double check. Is that the answer that they had?
I don't know. That's what I got.
Probably, it seems ridiculous.
Looks about right.
Okay.
It was, yeah, it was stupid like that.
Nasty like that?
Like,
That's a good problem. That's a good problem. I mean, there's a lot of math going on
Like,
in
why
there.
don't those two can't, no, because that's a pi, never mind.
Yeah. So you could factor out a 5/3 there if you wanted, you know, but you don't have to. I would just leave it like that. Okay? That's a good problem. I like that. You're getting some real, I mean, you're getting a lot of math with that. That's good practice.
So,
Okay, so then,
Questions?
oh yeah, requestees. Who wants to be requested?
so can we work for this period or?
Yeah, I'll let you work for the rest of the period. I'll push off anything new.